This lecture is for Chemistry in the Earth System, as we continue our lecture from Unit 1.1, Heat. The essential question for this lecture is how does thermal energy transfer, heat, cause substances to change state? How does thermal energy transfer, heat, cause substances to change state? Our first main idea is effect of thermal energy. Effect of thermal energy. When thermal energy is added to or removed from a substance, the effect is either to change the substance's temperature or to change its state of matter. A change of state is also called a phase change. It occurs when a substance changes among its solid, liquid, gas, and plasma states. If thermal energy is transferred to a substance, under most circumstances, its atoms and molecules gain kinetic energy, the energy of movement. This increase in average kinetic energy increases the temperature of the substance. When the substance's melting or boiling point is reached, however, adding more thermal energy does not immediately result in a further temperature increase. What it does instead is causes the substance to change state instead. In a substance, the electrical potential energy between atoms and molecules is stored in the form of intermolecular forces. During a change of state, the additional thermal energy allows particles in the substance to overcome the intermolecular forces which are holding them together. The average kinetic energy of the particle does not change. The temperature of the substance remains constant. Only when the phase change is complete, meaning all of the substance has moved to a new state, does additional thermal energy cause the temperature increase to resume. The principle is also true in reverse. As thermal energy is removed from a substance, the average kinetic energy of its particles decreases. Therefore, the temperature also decreases until the substance reaches a phase change point. Then, the temperature remains constant while more thermal energy is removed. Only when the phase change is complete will further removal of thermal energy cause the temperature to resume its decrease. For rising temperatures, the temperatures at which phase changes take place is called the substance's melting point and boiling point. For falling temperatures, these same temperatures are known as the substance's freezing point and condensation point. Phase change temperatures are not the same for all substances. For example, while the solid to liquid and liquid to vapor phase change temperature for water are 0 degrees Celsius and 100 degrees Celsius respectively, those for silver are approximately 962 degrees Celsius and 2212 degrees Celsius. Not only must a substance be between a certain temperature in order to phase change, it must also gain or lose a certain amount of thermal energy. The heat needed to change a certain amount of a substance from a solid to a liquid phase without changing its temperature is its latent heat of fusion. Latent heat of fusion, sometimes referred to as molar enthalpy of fusion. The heat required to change a certain amount of a substance from a liquid to a vapor, which is gas, without changing its temperature, is its latent heat of vaporization. Latent heat of vaporization, sometimes referred to as molar enthalpy of vaporization. Water, for example, requires about 334 kilojoules per kilogram of thermal energy to transition between the solid and liquid form. It needs 2,260 kilojoules per kilogram of thermal energy to transition between liquid and gaseous states. The amount of thermal energy a substance gains in a phase change is the same amount of energy it loses in the reverse phase change. For example, the same amount of thermal energy added to a solid to melt it completely must then be removed from that liquid to freeze it back to the solid state. Whether a substance changes state at a given temperature is affected by various factors. However, under special conditions, thermal energy can be added or removed from a substance such that it does not undergo a phase change as it normally would. The temperature continues to increase or decrease past the phase change points. The substance is then said to be superheated or supercooled, and it is unstable. The phase change is likely to occur suddenly when conditions shift ever so slightly past that point. At this point, you should be able to generate a full and complete response to today's essential question. How does thermal energy transfer, heat, cause substances to change state?